expand the following brackets. Remember that to expand some of the larger powers, you have to use FOIL, or the distributive law. Of course, anything to the power 0 is equal to 1, and anything to the power 1 is just itself. To expand the third, we must use FOIL, and then the process becomes a little bit longer. So this becomes a plus b times a plus b times a plus b, but we can replace the second two a plus b's with our answer from the previous question. And although we still have to use distributive law again, this does speed up the process a bit. And so we can repeat this process to get the expansions for the last two. Now before you click continue, take a look at all these expansions and see if you can find any patterns. One of the simple patterns that you may see is that for any expansion, the number of terms is equal to one more than the power. So for example, in the expansion of a plus b to the power 3, there are 4 terms. Another pattern that you may notice is that each expansion starts with a to the power of the bracket and ends with b to the power of that same bracket. What we're going to focus on for now is the coefficients. And to do that, we're going to strip away all the variables. Before you click continue, rewrite each expansion using only the coefficients and not the variables, and see if you recognize what these numbers look like. When written without the variables, these coefficients, written in this triangular way, should look like Pascal's triangle. Now we saw Pascal's triangle introduced to us in the unit introduction.